Hi everyone, myself is Kantaraj HD, Assistant Professor in Mathematics, Government First Grade College Government, Kernagar. In this video, we are going to discuss on one more reduction formulas. So that is reduction formula for integral of tan power nx dx and integral of cot power nx dx. First, let's derive the reduction formula for integral of tan power n x dx. So we need to consider the integral function integral tan power nx dx as in. Then in is equals to integral of tan power n I rewrite as tan power n minus 2 into tan square. Then which is equals to in is equals to integral of tan power n minus 2 into tan square. We know the formula secant square minus secant square x minus 1 into dx. In the next step, multiply this function with this function. We have in is equal to integral of tan power n minus 2 x into secant square dx minus integral of tan power n minus 2 x dx. So therefore, our reduction formula is reduced to in is equals to integral of this function is tan power n minus 1x whole divided by n minus 1 minus this function is nothing but I of n minus 2, because in is equal to integral of tan power nx into dx. Therefore, this is the reduction formula for integral of tan power n x dx. So let's see what happens if we take a definite limit from 0 to pi by 4 for that function. So that is in is equals to integral from 0 to pi by 4 tan power nx into dx. So by the reduction formula we have in is equal to tan power n minus 1 x whole divided by n minus 1 from the limit value 0 to pi by 4 minus integral from 0 to pi by 4 tan power n minus 2 x dx. So observe the first term of the RHS, tan power n minus 1 x whole divided by n minus 1. If we substitute upper limit, that is pi by 4, tan pi by 4 value is 1. 1 to the power n minus 1 is again a 1. Therefore, by the upper limit we get 1 divided by n minus 1 minus lower limit is 0. Tan of 0 is equal to 0. 0 to the power anything is 0. 0 by anything is 0. Therefore, this value is only 1 divided by n minus 1 and this function is minus in minus 2. So therefore, we get in is equal to 1 divided by n minus 1 minus in minus 2. Take this to LHS, we have in plus in minus 2 is equal to 1 divided by n minus 1. If we substitute n is equal to n plus 1, same will be reduced to in plus 1 plus in minus 1 is equals to 1 by n. This is the reduction formula when we give the definite limit for tan power nx dx from 0 to pi by 4. Next, one more reduction formula, that is reduction formula for integral of cot to the power n x dx. So as usual, we taken in tan power nx. Here also we take in as a integral of cot to the power n x into dx. So similar to the tan, we have to split this function cot power nx as a cot power n minus 2x into cot square x. So therefore, we have in is equal to integral of cot to the power n minus 2x into cot square x dx. So split means from the formula cot square x is nothing but cosecant square x minus 1. Therefore, in the next step we have in is equal to integral of cot to the power n minus 2x into cosecant square x minus 1 into dx. So multiplying this function and this function we get two terms, that is in is equal to integral of cot to the power n minus 2x into cosecant square x dx minus integral of cot to the power n minus 2x into dx. So if we integrate this function, we have minus cot to the power n minus 1x whole divided by n minus 1 minus I n minus 2. So only difference between the tan and cot is here we have negative sign instead of tan we have here, instead of cot here we have tan. That's it. So this is the required reduction formula for cot to the power n x dx. Let's see what happens if we take a definite limit to the sim function, that is in is equals to integral from pi by 4 to pi by 2 cot to the power n x dx. Here we can't take 0 because cot 0 value is infinity. Therefore, from the reduction formula of cot to the power n x, we have in is equal to minus cot to the power n minus 1 x whole divided by n minus 1 from the limit pi by 4 to pi by 2 minus integral from pi by 4 to pi by 2 cot to the power n minus 2 x dx. So, from the upper limit, cot pi by 2 value is 0. Therefore, whole function goes to 0. From the lower limit, we have cot pi by 4 value is 1. 1 to the power n minus 1 is again a 1. Since here we have negative sign, for lower limit, we have to take negative value. So, minus into minus, we get positive, that is 1 divided by n minus 1 minus all this function we considered as in minus 2. So therefore, as we did in tan function, here also we have in plus in minus 2 is equals to 1 divided by n plus 1. So let's see one of the example regarding this formula, that is evaluate integral from 0 to pi by 4 tan 5 to the power 5x dx. We note that the reduction formula for tan function, that is in is equal to 1 divided by n minus 1 minus in minus 2. So where in is nothing but our given integral, that is integral from 0 to pi by 4 tan to the power n x dx, where n value is 5 they given. So if we substitute 5 in our in, so this formula is reduced to I5 is equals to 1 by 4 minus I3. Next, put n is equal to 3. We have n is equal to 3. We get I3 is equal to 1 by 2 minus I1. And I1 is nothing but integral from 0 to pi by 4 tan x dx. So I1 is equal to integral of tan function is log of secant x from integral values 0 to pi by 4. So substitute the value, log secant pi by 4 is root 2. Therefore we have log 2 with respect to upper limit, and secant 0 value is 1. Therefore log 1 is corresponding to lower limit. So log 1 value already we know that it is a 0. Therefore I1 value finally it is equals to log of root 2. So then I consider this function, that is I5 is equal to 1 by 4 minus I3. So which is equals to I5 is equal to 1 by 4 minus I3 here we have substitute this one to here. That is nothing but 1 minus of 1 by 2 minus I1. So which is equals to I5 is equals to 1 by 4 minus of 1 by 2 minus log root 2. Simplifying these brackets, we get I5 as a log of root 2 minus 1 by 4. So let's see one more example related to this reduction formula. So that is evaluate integral of cot to the power 6 x dx. So cot function, for cot function we know the reduction formula as in is equal to minus cot to the power n minus 1 x whole divided by n minus 1 minus in minus 2. So take n is equal to 6. So I6 is equal to minus cot to the power 5x divided by 5 minus I4. So therefore I6 is equal to minus cot to the power 5x divided by 5. Replace or apply reduction formula for I4. So we get minus of minus cot cube x divided by 3 minus I2. So which is equals to I6 is equal to minus cot to the power 5x divided by 5 minus into minus plus cot cube x divided by 3 plus apply the reduction formula for I2, we get minus cot x divided by 1 minus I0. So which is equals to I6 is equal to minus cot to the power 5x divided by 5 plus cot cube x divided by 3 minus cot x divided by 1 minus integral of 0 tan power 0 dx. Tan power 0 value is 1. So we have integral of 1 dx. So 1 dx is nothing but x. Therefore our final value of integral of cot to the power 6 x dx is I6 is equal to minus cot to the power 5x divided by 5 plus cot cube x divided by 3 minus cot x minus x. This is the answer for integral of cot power 6x into dx. This is the very important measure applications of reduction formula by solving the functions having the higher powers. Okay, thank you.